We can compare the properties and behaviours of gears using the ratios of their radii. Now, gears work by transferring moments through contact forces as the teeth of the gears move past each other. So in this example, we can compare the radii of the gears. The two smaller gears each have a radius of 0.4 metres, and the larger gear has a radius of 0.6 metres. Ratios can be used to compare the size of different values, and they can be scaled up or down like fractions. We can work out the ratio for the gears by multiplying each radius by 5 to get whole numbers. We then end up with a ratio of 2 to 3 to 2. But what's so important about this ratio? Well, the moment experienced by each gear follows the same ratio. Remember that moments are the turning effect from a force, and they're equal to the force multiplied by the perpendicular distance. Gears require an input force to start turning, and then there is the same reaction force at each contact point between the gears. For each gear, the perpendicular distance is equal to the radius, so if we multiply that by the force, we get the moment of the gear. The ratio of the moments is the same as the ratio of the radii, and this is because the force is the same for each calculation. So the ratio can just simplify to the ratio of radii. So what else about the gears follows the same ratio? Well, the time it takes a gear to complete one rotation also follows this ratio. So if we imagine a dot drawn on the top tooth of a gear, the time for one complete rotation is how long it takes for the dot to be at the top again. In order for the gears to stay connected, they must all rotate at the same speed. The larger gear therefore takes longer to complete a whole rotation, as it has a larger circumference, so there's more distance for it to turn through. The ratio of the rotation times is the same as the ratio of circumferences of the gears, which again is the same as the ratio of radii. So how exactly can we design the gears so that we know what these ratios will be? Well, the number of teeth each gear has follows the ratio to allow the gears to have these rotational frequencies. So the number of teeth varies in this way, as we want the space between the teeth and the size of the teeth to be the same for all gears. The larger gear just has more circumference to cover. Therefore, the ratio of teeth is the same as the ratio of radii, as the number of teeth depends on the circumference. You should be able to explain why the ratios are related in this way, and also be able to use them in certain exam calculations. Let's have a look at an example. A pair of interlocked gears has 8 and 32 teeth respectively. The gear with 8 teeth has a radius of 0.15 metres and is given an input force of 5 newtons to make it turn. Calculate the moment that the gear with 32 teeth receives from its reaction force with the other gear. So we can solve this problem by using the ratio of teeth to work out the information needed about the second gear. So for step 1, let's determine the ratio of the teeth of the two gears. So the first gear has 8 teeth and the second has 32. We can divide both sides of the ratio by the same number to make one side 1, as this makes the ratio easier to work with in the next step. So here we can divide both sides of the ratio by 8, and that gives us a ratio of 1 to 4. For step 2, let's calculate the radius of the larger gear. The smaller gear has a radius of 0.15 metres, so we can multiply our ratio by 0.15 on both sides, giving us the ratio of radii, and that becomes 0.15 to 0.6 metres. So the radius of the larger gear is 0.6 metres. For step 3, let's determine the size of the reaction force on the larger gear. Now the reaction force is the same as the input force, and that is 5 newtons. Then for step 4, let's calculate the moment acting on the larger gear. The moment is equal to the force times by the perpendicular distance, which in this case is equal to the radius. So the moment is equal to 5 newtons multiplied by 0.6 metres, and that is 3 Newton metres. We also could have calculated the moment of the first gear and used the ratio of teeth to find this moment.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!